Hey guys, you can start the presentation.
Good morning, everyone. We are from. All right.
And
Uh, we have water. And I am kind of my group member. I'm with Dean and Noor Shazwani. Next slide, please. Next slide. These are our table of contents. All right. Let's first start with what is the solar thermal water? All right. It's a device water by using a sunlight uses thermal collector, and it's also called as the solar domestic hot water system. And it's used it's used by heat exchange between fluids in the storage free. And when it invented, it's back to the 218 before Christ, and nowadays most of those countries, modern countries, are planning to use the solar in general. So China is become the biggest country in the world that manufacture solar water heat. Next slide. Of a solar thermal water system. There is two types, active system and there is a passive system. Let's start with the active system. It's divided into three parts. It's a direct system, antifreeze, and drawn down system. All right, let's start with the direct system. It says this system pump water from the storage to collector during a sunny hours. Freeze production as obtained by a recycling hot water from the storage tank or by flushing the collectors. Since the recirculation system is increasing energy use while flushing reduce the hours of the operation. Direct circulation systems are used only in the areas where freezing temperature are influenced. All right, and then antifreeze system. In this system, the free conducted fluid is circulated through a closed loop, and its heat is transferred to the potable water through a exchanger with the 80 to 90% of efficiency. Here is pumped through a collector is a closed loop. The loop, including the collector, connecting pumping to the pump and expansion tank and a heat. Next. Yeah. And then the last one in the active system is a drawn down system. This system are generally direct water heat system. Water is circulated through a closed loop and heat is transferred to the potable water through a heat exchanger. When no solar heat is available, the collector fluid is drawn by the gravity to avoid freezing and convection loop in which cold collector water reduce the temperature of the storage water. And let's go to the passive system. All right, there is integral collector system. It is hot water storage system is the collector. Cold water flow gravity progressively through the collector, whereas the heated by the sun. Water is drawn from the loop, which is the hottest, and replacement water flowed into the bottom. This system is simple because pumps and collector are not required. And let's go to the thermofan system. These systems are not usually suitable for the large system and force-free region. The fluid races by the natural convection from the collector to the storage tank, which is placed at a higher level. No pumps are required. These systems are most efficient in area with the high level of solar radiation. And thank you so much. I'm gonna pass it to my
Okay,
hello.
um, hello.
Yeah,
Um,
yeah.
all right. There's four basic components of solar water system. The first is collector. The panels in the solar thermal system are known as collectors and are typically installed on the rooftop. And these collectors are different from the photovoltaic solar panels because instead of generating electricity, they generate heat. Second is a series of pipes known as a heat exchanger, which is located inside the storage tank, and the heat is transferred from pipes to the water. And we also have control system to ensure the water in the storage tank doesn't get too hot and prevent cold water from being cycled through the system when it's extremely cold outside. And lastly, we have backup heater that usually either a gas boiler or an electric immersion heater. It is used when it's too cloudy or too cool outside to generate enough heated water from the solar energy. And how it works, the first the first thing is the solar panel collector will capture the energy and generate heat into a solar heating fluid inside these tubes. And then when there's enough heat available, a controller will allow the flow of the heating fluid into the storage tank. And the hot solar fluid transfer heat to the incoming cold water in the storage tank as it travels through series of pipes inside the storage tank. And then the water in the tank is heated and can be distributed for usage. And the solar fluid leaving the series of pipe in the tank flow back to the collector to be heated up again. And on colder and cloudy days, the water temperature is boosted by a backup heater, gas boiler, water immersion heater. The application, the solar swimming pool. Solar swimming pool can significantly reduce swimming pool heating costs and has a very high efficiency. There's four components: solar collector, the device through which pool water is circulated to be heated by the sun. There's flow control valve, an automatic or manual device that divert pool water through the solar collector. There's pump that circulates the water through the filter and collector back to the pool. And there's filter that removes debris water is pumped through the collector. There's factors of heat losses and heat gains of solar swimming pool. The factor of heat losses is evaporation, radiative losses, and convective heat losses. This is the largest and the second largest heat loss factor that can both be reduced with pool cover. And the factors of heat gains is direct radiation for outdoor pool, but you have to use transparent cover. And lastly is the solar collector. I'll pass it to my friend for cost analysis.
Okay, so Assalamualaikum, good morning. For the cost analysis of solar thermal system, first there's a collector efficiency rating and efficiency dependency and evaluation evaluations procedure, which includes estimate daily water heating load, determining the solar resource, calculating solar system size, calculate annual energy saving, calculate annual cost saving, estimate system cost, calculate saving to investment ratio, and lastly, simple payback ratio. So first, I'm going to start with an collective efficiency rating. So the formula for efficiency rating is mu solar equal to Q useful uh, IAC, which is the useful heat from collector divided by incident times and collector area. And for the Q useful, which is the useful heat from collector, is equal to incident times absorptivity times transmitti- transmissivity and collector area minus thermal loss coefficients times collector area and the difference of between storage water temperature and outdoor ambient temperature. And for the next slide, um, next slide, yeah, it's about the efficiency dependency. So the percentage of solar captured by collectors determined by the type of collectors, which are the Ugly's EPDM collector, flat plate, evacuate, evacuated tubes, and parabolic tube. Yep. For the next slide. So for the evaluation procedure of water heating sources, daily water heating energy load. Um, in the formula is L equal to MC and difference between temperature, hot and cold. So L is daily hot water energy load, and in unit kilowatt heat per day is equal to mass of water per day times specific heat water heater and the difference of hot temperature and cold temperature divided by mu boiler auxiliary heater efficiency. And there's a typical hot water usage use. So the properties for dormitory, motel, hospital, office, food services, residence, school, and barracks. Yeah, all of these will be listed below. Given. So for the solar energy resources, next slide. Yeah, you can see here there's difference between United States of America and the global for the resources, and regulations can be different because this one I use the reference from the United States, which is from the NREL dot gov. So list down all the locations given there, including IMAX and I average. Yeah, that's like. So for the solar water heating system size and delivery. Solar system size, the formula is included collector area equal to daily load divided by efficiency of solar system, which is typically 0.4 times maximum dollar solar radiations, and for the annual energy saving is equal to um, collector area times I average mu solar 365 divided by mu boiler. Yeah. Next slide. So for the solar water heating system cost and saving. So solar system cost, the formula is C equal to C solar times AAC. And you can see the difference of properties that we listed down below because I used the reference from United States of America. So you can see the difference in for large systems, small system might be an average, and different properties in electricity, natural gas, water heating, oil, and propane and kerosene. But the formula is still the same, just a different properties. So yeah, next slide. So for the last part is 7 to investment ratios and payback period. For the 7 to investment ratio, first is S times PwC, which is the present worth factors divided by C, which is solar system cost. So project is considered to be cost effective is the equal is above 1. So the simple payback ratio, SBP, equal to C divided by S, and considered to be cost effective if the result is below than 10 years. And for the solar fraction is equal to AC times I average mu solar divided by L. And if the condition is to meet 30% requirement size, it will be AC equal to 0.3 times L divided by mu solar times I average. Okay, for the example for 4 persons resident in Austin, Texas, and against electricity. First, we need to find the value of the conditions. So yeah, for the mass of water per day. So it's 4 persons, which is 40 gallons per person's day times 3.785 kilogram per gallon. So we get 606 kilogram per day. And for the daily hot water energy load, it's the answer before we will times 0.001167 and times the difference between hot and cold energy, we will get 22.6 kilowatt per day. And for the conditions of Austin, Texas, the I max is 6.3 and I average is equal to 5.3. And there is the conversions will be 9 millimeters square. And for the ES, which is the annual energy saving, we would get 7,914 kilometer watt per year. Yeah, and the next is solar system cost, which is dollars in current dollar currency, about 19,269. And the next is annual cost saving, around $842 per year. And for the third value, serving to investment ratios, is about 1.01, 1.03. And for the payback ratios is below 10 years, which is not project cost effective. So there's need to be certain changes, maybe in the solar system size. So yeah, for the next slide, I'm gonna pass it to someone else. Thank you.
Next slide. Next slide, please. Okay, so for requirement for success items are appropriate application, boleh okay, so requirement for success items are appropriate application, proven design, freeze protection, properly sized, required no manual intervention, operational indicators or monitoring, conservation first, verify load performance guarantee, and required operation and maintenance manual and training, and lastly, acceptance test. So for conclusion, next slide. Sorry. Okay.
Sorry, internet lembab.
To conclude, solar thermal water system can provide us a clean energy and better alternative for the environment. So the source for the system is free and it is renewable. Therefore, it should be harvested and benefited from especially in country like Malaysia where we are mostly exposed to the sun all year round. So although it is a bit expensive to install, it is a relatively cheaper option than other system considering its annual cost. That's all from our group. Thank you.